in this video, we're going to go through the Redox titration lab and the expectations of what should be included for each part. All right, so you're going to be typing the lab report, and according to Google Classroom, these are the parts of the lab that you're going to need to do. So you have a data table from the lab, okay? So you should have something that looks like this from the lab. Now, you filled this in from the lab. You're just going to recreate the data table in Google Docs, okay? So that's the first part of the lab. Second part of the lab is going to involve your calculations, okay? So we didn't do the entire lab. We just did the first part. So there are 3 calculations that you need to perform, okay? The first says moles of iron, okay? Moles of iron. So from the data table, or actually from the procedure rather, we know that we used 0.1 molar iron 2 ammonium sulfate solution, okay? So there's your molarity. And then we also, if you read further into the lab, we use 10 milliliters of that iron solution, okay? So let me just kind of simplify this for you, or write it out rather. So we're going to be using the molarity equation. Molarity is moles over liters. So you know the molarity, you know the liters. Actually, you know the milliliters. You need to convert that to liters, and then you're going to solve for the moles. Okay, so that's your first calculation. All right, the second calculation that you're going to need to perform is the moles of your permanganate. Okay, now on your data table, it gives you the molarity. Okay, the problem is we don't know the molarity of our permanganate. Okay, so the whole point of our first titration is to figure out the molarity of our permanganate. It's supposed to be 0.0250 molar, but you know, things happen when you mix it. It's not going to be exactly that number. So the whole point of our redox titration is to figure out exactly what the molarity is using the known molarity of our iron and the amount of our iron that we used, along with the amount of our permanganate that we used. Okay, so to find the moles, we have our moles of iron, and if you go back and look at the pre-lab, the very first question asks you to balance the unbalanced skeletal equation for the standardization of the permanganate solution. Okay, so you're going to need to split this into 2 half reactions and balance it under acidic conditions. When you're all done, you'll have a complete balanced equation for what we did in the lab. Okay, so you should have already done this, but you need to type that out in the lab. Okay, now once you have that equation, you're going to go from moles of iron to moles of your permanganate using your balanced equation. Okay, so look at your notes if you need to for what we did to go from moles of one thing to moles of another using our redox titration. All right, the third thing that it asks you to do in the lab is it asks you to calculate the molarity. Okay, so once you get to your moles of permanganate, okay, so once you find this in part B, you're going to go back to the molarity equation, which again, molarity is moles over liters. So you should know the moles from part B. Okay, you should know the moles from part B. And then on your data table, once you subtract the final and the initial volume of your permanganate, you'll have the volume of the permanganate that you added to the flask. Okay, so you're going to take the volume that you added, you're going to need to average your 3 trials. The volume added is going to be your volume of permanganate. So let me just write this in here. So this is the volume added. And that's going to be an average of 3 trials. Now, if you over titrated, do not use that trial. Okay, so I mentioned in the lab when we were doing this to make a note on your data table if you over titrated. Okay, so use 2 of the 3 if you over titrated 1. Okay, so those are the calculations. Okay, now for the conclusion, you need to state the purpose. So I kind of alluded to that earlier. We have permanganate that we used in the lab. It's supposed to be 0.0250 molar, but we don't know exactly what that molarity is. Okay, so we do the standardization titration to figure out exactly what that molarity is based on what happened in the lab. Okay, so that's essentially the purpose. I need you to kind of, English that up a little bit better and put it in your own words. Okay, and then the results, I need you to compare what we did from, I'm sorry, not compare. I need you to compare your value, what you actually got in the lab, with what it was supposed to be, which is 0.0250 molar. Okay, so what did you get in the lab? What was it supposed to be? Okay, those are the results. The explanation, you're going to put in your own words what a titration standardization is. Okay, so look at your notes if you need to. We went through this in class. Feel free to bring in other explanations that you're able to find online if you need to. Whatever you need to do to explain it in your own words. Okay, now the last thing that you need to do in your explanation, like I said, the actual molarity that you calculate in the lab is probably going to be different from 0.025 molar. What could have caused the molarity to be different? Don't think about this too hard. Just think about when you make a solution, you got your solute, which is the solid that you're dissolving, and then you have your solvent, which is the liquid that you're dissolving it into. In this case, it was water. If the molarity is too high, what would that mean? Is there more solute or solvent? If the molarity is lower than what was expected, what would be higher, the solute or the solvent? Okay, so kind of talk about that. And again, if you're not sure, feel free to go online, Google some reasons why your molarity might be off, and type that out in your own words. So that's essentially what I'm asking you to do for the lab. And feel free to ask questions if you need to, come in for help. But hopefully this video helps you get this done. Good luck.